All right, what I want to cover today is finish covering what we were covering the other day, and that is the vectors. Now, you're going to see a lot of two things in calculus, especially calculus 2. That is vectors and polar coordinates. So you need to know the difference between the two, as well as how to work them. It's very basic. If you know how to do the Pythagorean theorem, pretty much you can do both of them. Vectors are a way that we talk about with magnitude and direction. And with magnitude and direction, if you have two or more vectors, you need to find the resultant vector. I think we talked about that a little bit before class ended the other day. For every vector, there is an opposite vector. We talked about that. And scalar product, scalar vector, is basically a coefficient in front of the vector, like 3 times vector v. So it'd be, instead of just vector v, it'd be 3 times that, which would be a longer one, and that's what they're showing you here. Here's the basic vector u. 2u would be 2 times that, which would be up here. 3 halves would be 1.5 times. Half of u would be half of that black line. And negative 2u would be that line going backwards multiplied by 2. So just remember a scalar. Scalar, just put scalar equals multiply. And that means that if I have u, and I tell you on a test I want to see a vector 2u, then you would just double that. Take your ruler, measure that black one, and add it on and make it a different color. That's what a scalar vector is. It's something that is multiplied evenly. Okay? I like to tell students, think of a scalar as a coefficient. You know, the coefficient 2 in front of 2x. Well, scalar is pretty much that, only when it's talking about a scalar, you're talking about vectors. Sure, it is. Okay. A vector coming from the origin is called a position vector. Now you're going to hear that a lot in Calc 2. So make sure you write that down and put it to memory, because the Calc 2 instructor is going to think, okay, they know what a position vector is. And that is a vector that comes from the origin. Now your polar coordinates are like position vectors. All right? Both of them are basically the reason you have position vectors is for Calc 2 when you get in there and calculate Calc 3 when you actually trace a particle in space. So you have a particle right there. And that particle is going around like this and going around like this. Okay? There's the particle in space. At one point in time, the position vector is going to be right there. Okay? And that's going to be in form of a x, y, and z coordinate. Alright, so what they're doing is getting you ready for Calc 2 and 3 terminology with these steps, with these units. Alright? Just letting you know that, because I don't want you to think that you have to master all the vectors and all of polar coordinates in this class. You don't. You just get an introduction to it and feeling your way through. A position vector u with endpoint AB is written as u is equal to AB with the, I don't know what you call these things, but whatever they're called, less than or greater than, whatever. That means that that is a position vector. Now you're going to see there's different ways of writing vectors in Calc 1 and Calc 2 and Physics 1 and Physics 2. But you need to start off with the position vector is written as that. Okay? Where X is A and Y is B. All horizontal function. That's basically what they are. And there is how you find the magnitude. This is important, very important. And of course, where do you get that from? Where do you get this from? Pythagorean theorem. Okay? Notice that this is absolute value. Why is it absolute value? Because the hypotenuse can never be what? Negative. So therefore you're finding the hypotenuse of a triangle. Okay? If I give you a point right here, okay, and I'm going to show you this in the next section, that point is a what? Coordinate. I like to tell students it's like a house. Okay? In order to get to a house, you got to have what? Get to a house. A driveway. The vector is the driveway. Okay? And the position vector has a coordinate of, beginning coordinate of what? 0, 0. So if you actually take the distance from the coordinate to the, from the coordinate to the beginning coordinate, then you're going to find basically the magnitude of the vector. All right. So if this is 3, 2, then that means this direction is 3, and this direction is 2. So do you actually need this? No, you don't need it. All you need to do is remember the Pythagorean theorem. And that's going to be 2 squared plus 3 squared is equal to 4 plus 9 is what? 13. And 13 is equal to the square root of 9 is 3. Square root of 4 is 16. 3.5. 9 and 16 is 5. Add 2 would be 11. 12.5. So it's around, I forgot what I was talking about. 3.5. It's around 3.5. So you just found the magnitude of this. Now, what else can you find now that you found the magnitude? What can you do, knowing your trigonometric experience now, what can you do? You can find the angle from 0 to here. So that's all you're going to be doing with it. And you're going to find out this, that x is equal to r cosine theta, and y is equal to r sine theta. Now, you know how I remember that to this day? That's how you have to, is I put a little stop sign on here, and the sine is vertical, the y is vertical. That's how I remember. Actually, I used to draw y like this, like that, and I would remember that part right there. And that's how I remember it's cosine and sine. All right? But that's why you have to remember things like that. These 3 formulas right here are what you're going to be tested on in 10.3. Okay? To make sure you can go backwards and forwards. You'll see it on the next page. Don't worry about it. All right? First of all, look at this. Position vector 3, -2. First thing you're going to do is draw it. And I'm going to draw it pretty big. And that's 1, 2, 3, 1, 2. So there's your house. And driveway to the house is called a vector. And you can go ahead and say 3, -3, -2. So that's going to be the hypotenuse is equal to the square root, or the magnitude of the position vector, is equal to the square root of a squared plus b squared. And this is going to be 3 squared plus negative 2 squared. And that's going to be equal to the square root of 9 plus 4. And that's 3.6. I know. 3.6. Now, we wanted to find, if we were going backwards, then they would give us the theta. But let's say we want to find this angle. We want to find the direction. Well, the little man's sitting here. So his foot is on the adjacent and hypotenuse, so that means this is equal to the opposite. You pick what you want. Oscar had. So sine. Sine of theta is equal to Oscar, negative 2, over what? 3.6. And you really don't need the negative. The negative is always going to tell you that it's in the third quadrant, but it's whatever you want to do. Whatever. Whatever, I don't remember. That's it. Okay. Sine inverse of negative 2 over 3.6. What do you get? Make sure it's in degree mode.
$33.75.
34 degrees. Now, of course, that angle right here, this is 34 degrees. So this angle is what? Whatever, 326 degrees. Somebody check it for me. 326 degrees. Check it. Yep. Okay, so see, this is what you have to. You should be able. Right now, you should be going to yourself. Oh, I know how to do that. That's what you should be saying. If you're saying, "Oh, I don't know what he's doing," then you've missed the whole boat train, the whole semester. Okay, so don't raise your hand and say, "You what you're talking about." I don't know who I'm talking about. But if you're saying to yourself, "Oh, I see where this is going," then that's a good thing. All right. And there they go. They're doing the same thing we just did. Except they're probably going to write it as square root of 13 because this is academia, not the real world. The real world would want 3.6. Okay, they got 33. They got 34 degrees. They used the tangent, which you could. That's fine. And they got 326 degrees also. All right. There's your r sine theta and r cosine theta. It's written a little bit different, but you need to remember r sine theta and r cosine theta because that's what you're going to see in calculus. You're going to see r sine theta and r cosine theta. And this is the way you'll see it. X is r cosine theta, and y is equal to r sine theta. Basically, just remember these two. The little r is the position vector. That's basically the hypotenuse. The little r is the hypotenuse. Big R is the result. Okay, so I don't feel like I have to spend a lot of time on this because if I tell you that a vector is going like this, and the angle is 65 degrees, and the magnitude is 4 units. That's the magnitude, meaning 4 inches, 4 miles, 4 tons, whatever, 4 pounds, whatever the units are. Then what would you do to find your x and y? Well, the x would be equal to 4 cosine of 65, and your x or your y would be 4 sine of 65, and then you just plug each other. Okay, you wouldn't have to find a hypotenuse here because the hypotenuse is over. So chances are these two are going to be less than what? 4. Because you have 4 as a hypotenuse. Okay? Again, you should be saying to yourself, okay, I see what he's doing. He's finding the x and the y of the triangle. Yep. Very important. So you got your Pythagorean theorem, and then this. Very important. Here they give it to you. So do that one right quick. Okay, they did it for you. Oh well. If it is, they just want you to type it in the calculator. So type it in the calculator. They don't even give you, they just tell you what the answer is. So, and you should get 18.7 and 16.6. I guess they want you to check to see if your calculator's in degree mode or not. Because there's no reason. They should have let you at least do the problem. Maybe. I don't know. Okay, there we go. Two forces of 15 and 22 newtons act on a point in the plane. If the angle between the forces is 100 degrees, find the magnitude of the resultant force. Yeah, but they're jumping. Why are they jumping from? Something's wrong. That's the result. That's two forces. Why are they doing this? It's kind of like, okay, y'all know how to deal with one force. Okay, now we're going to jump to 2 and just right at it. They don't even explain or anything. Okay, two forces of 15 and 22 degrees act on a point. All right, in the plane. If the angle between the forces is 100 degrees, find the magnitude and the resultant force. So as you saw in the picture, first of all, you need to draw a picture. So you got one, and I'm just drawing it because I saw what they did. You got one going that way, and it's 15 degrees, because it's first. And then another one going this way, and it's longer because it's 22 degrees, or 22, and they're 100 degrees apart. And that means you need to draw another one down here, and this one right here. And that's 100 degrees. That's 100 degrees right here. That's a quadrilateral, right? Yes, you would. Well, that's a quadrilateral. How many degrees are in a quadrilateral? So 360 minus 200 is what? 160 divided by 2 is what? So that's 80. That's it. I don't try to. Now your resultant vector, which they had kind of skipped over and hadn't even shown you. I don't understand why this question is here. The resultant vector is right there. Okay, now if you did head to tail, you would take one of these and put it to the head of the other one to get the same thing. Alright? So now you need to. This question is out of place. But we'll go ahead and go through it. And that's what they're showing you there and there. Okay? So you got 15, but they kind of turned it around. I knew they'd do it past that from the way I did it. But anyway, if they mention 15 first, you're supposed to put it second. If they mention the second, you're supposed to put it first. Alright, whatever. It's the same thing. There's drawing. Now, there's your vector, and they're using the law of what? Looks like the law of cosines. Okay, so they just went through and didn't even explain that, did they? They just went through and yeah. So I think they've missed. I think they've deleted a slide in here somewhere. But that's what they're doing. They're finding the length of that resultant vector by the law of cosines. So look, go ahead and write that down. Is equal to A plus B minus 2 times AB cosine of C. Basically what they're doing. Because you got an angle, side, and an angle. Side, angle, side.
Incoming message.
Right here. Side, angle, side. Or do it here. Side, angle, side. So they found the resultant vector at 24 using the law of cosines. The only angle you have here, and some of you might not understand why it's the law of cosines, the cosine of 80. Just draw me a picture. 15 goes here. But this angle is some letter of 15. I'm just going to call it A. A, little a, is equal to 15.
You're split 100 to do that triangle. So that would be 50 to 80. So 100. No, it's still not. It's not equals house.
Okay. Settle down. All right. Now, this is B. So it's going over here. Okay? So this is B. And then this is what? C. And this is angle what? This is line C. So now you see what you have. You have A, B, and that's why you can't use the law of sines. You can't use the law of sines because you don't have C. And you don't have an angle for A or B. So you're going to have to use the law of sines. Cosine, sorry. And that's why the cosine of 80 is right here. And they're saying right here, okay, this is C. And that's why this is C. Because A and B are already given. I'll erase this and you'll have to look at it. There. You need to do it again? Okay. I'll do it different colors. Alright, let's go with blue. Alright, I have this side. I'm just going to call it A. Why am I starting with A? Because the alphabet does not start with C. Alright, that's A. So I go across. Right there. And that angle right there is angle big A. We don't have angle A. Alright? We could assume it's 50 degrees, but does this look like it's bisected? No, so you have no way of telling if this is bisected or if it's just split, because that looks like a third, this looks like 2/3. So you can't just start guessing. Then we don't know, I'm saying period, yeah. Okay? Then you say it's purple, and I got this angle, we call it B. And it goes right here. Okay. Side B, and therefore this angle right here is capital B. So the only letter left in the alphabet we have to use is what? I'm not adding the first big stuff. We'll use color chart. Let's see what you do. So that means that color is C. And look what it corresponds to. What we're trying to find. Little c. And that's why you have this. So they use the law of cosines with angle C given. Okay? Is this question out of place? Yes. This should be at the end of 10.3 with an explanation of what a resultant vector is. I think it's misplaced. It should have been put with those other the other slides that had the resultant vector where it did head to tail, that's where it should have been placed. It was kind of misplaced. And remember to take the square root of it. And it's 24 newtons. See, all this should have been, the slides are misplaced. Okay, that's how you find the x and y. Right there, you add them together. That's what they're saying. Put this in, put it up here, and then you can just add a plus a and b, a plus c, comma, b plus d, and that'll be the coordinate for this point right here. So you might want to write that down if you ever want to find a coordinate. Hopefully they'll give us an example. That problem we just did should be at the end of these slides. Damn Russians. No. Real estate agent. I wish he'd sell all that property so I could pay off my house. So I wouldn't have to make payments anymore. All right. They'll probably give us an example. Nope. Okay, we just did that. They're telling you here if they want the opposite vector and they give you a and b, then you put a negative sign in front of both of them. Duh. And you can add those two together also. But you have to remember the negative. You have to remember the negative. I'm not going to spend a lot of time on that. Okay, here's two position vectors. Go ahead and do it. Draw it if you have to. I'm going to draw it. Two position vectors. Let's do the red and black. We'll do the U in red, -2, and +1. So there's my U vector. And I'll do the blue, if it's Superman colors. That'll be 4. And there is my V vector. Now, if you wanted to add those two, you just take that red vector and do what? Put it up here and find the resultant vector. I'm going to just draw it. So I'm going to take my red and I'm going to draw it up here. Like that. Draw it the same magnitude and direction. So now I'm going to take this light blue and the resultant vector is going to look something like that. That's the resultant vector. They call it R. And that's just for later. I don't know what they even want. They don't want it. So, all right. So now we've got A plus B. So let's take A plus B.
Unsecured channel.
And A. What? Okay. Sorry.
Just so
Yeah. U is -2, comma 1. Hold on. What does that do? Let's go with red. There we go. Okay, so -2, comma 1 plus blue 4, comma 3. So what's -2 plus 4? 2. And 1 plus 3? So that is your answer to that. So B, -2U. Well, this is pre-algebra stuff. -2U. So -2 times -2, comma 1. And that's going to give you what?
2 -2.
-2 times -2 is what?
Priority 1 message coming in on secure channel.
4. And -2 times 1 is?
-2.
And then you try the third one. Try C. So 3 times U. C. 3 times U. What's 3 times -2? And what's 3 times 1? Minus, what is 2 times 4? And what is 2 times 3? And what is -6 minus 8? -14 too. And what is 3 minus 6? So you're doing the last part of trigonometry, college trig, and all it boils down to is multiplying something times something. Remember the binomials? 2 times x minus 2 plus 3 times x minus 6. What are you doing? You're distributing. That's what you did with this right here. This -3 and that 2. You distribute it, and now what do you do? You 2x minus 4 plus 3x minus 18. Now what do you do after you distribute the three algebra? Combine like terms. And that's what you're doing now. You're adding the x, and then you're adding the what? You're adding the y. You did three algebra. You do the same thing. Okay? Question? And that's basically what they should have got. I'll check my answers and see if we got the same thing they got. Did we get that? Okay, good. Okay, here is the second most common thing that you're going to see in Calculus 1 and 2, the unit vector. A unit vector is just like a radian. It's a vector with a measurement of what? 1. Write that down. Unit vector is a measurement of 1. So 3 times the unit vector would be 3 times that vector, which would be 3. That's just a good thing to know. Make sure you write it down and highlight it. Dot product. I'm just going to let you look at that. You can write it down however you want to. It's basically a way that you multiply vectors. All right? But it is not a quantity. It is used for calculations. Write that down. The dot product is not, it's basically a multiplier. When you get through with the dot product, you're going to use it to multiply something. All right? It is not a vector. It is a multiplier. So what do? Well, you multiply the x and the y, and you multiply the x and the x, and you multiply the y and the y, and then you add them. Now, it's very important that you understand that this is not a vector. The others are vectors, or make a vector. See, this does not have an x or a y. Okay? It doesn't have an x or a y. It doesn't have an r or an I. It doesn't have anything. It does. So it's just a multiplier. It will, or I don't know if this will use it in the future, especially in physics. It probably will in the next problem. You use it to find, you can use it to find the angle, usually to find the angle between two vectors. That's probably what they're fixing to show us. Okay, properties of the dot product. It is multiplicative. It is commutative. 2 times 3 is the same as 3 times 2. The u dot v is the same as v dot u. These are just properties. You can multiply by a scalar. You can distribute, just like right here. You can distribute the k. Anything times 0 is what? 0. If you take the unit vector and multiply it by the unit vector, you get the unit vector what? Squared. So these are just some properties. Just write them down right quick. They're not detrimental to you making A on this test, but it's, you need to write them down. Okay? You don't have to write all this down. Just make a note of them. Properties of dot product. Basically, they're the same as any number that you multiply. You multiply 2 times 3, the same thing as 3 times 2. If you multiply 2 times 3 plus 6, it's going to be the same thing if you distribute the 2 times 3 plus 2 times 6. I'm not going to go through all of those because they're pretty basic. There we go. Here's where we use the dot product. See, the dot product is right there on top. See it? U dot V. There's the dot product. There's where you use the dot product. There's the dot product. And what are these? Magnitude of U and magnitude of what? And what do you do to get the magnitude of U and the magnitude of V? It's not given. Pythagorean what? Pythagorean theorem. Usually it's going to be given to you, or there'll be the points to find magnitude. This right here is another way to find the dot product if you're only given this information. All right? This is finding the dot product when not given coordinates. Okay? So if you're not given the coordinates, then you're going to have to be given something else to find the dot product. And that's it right there. Now, what if I give you two sets of points for U and V? Can you find the angle? Yes. Because U and V, I give you two sets of points. You can find what? You can find magnitude, and you can do the dot product. You can find the angle. Before to find the angle, you have to use the law of what? Cosines. Now, you've evolved into another formula. That's this one. And this one. They should give us a prompt here in just a second. I hope. There we go. Now, you can do it either way. They give you coordinates. So you can find the dot product this way, or you can do it the U way. It doesn't matter. So go ahead and do it. I'd go ahead and do the Pythagorean theorem right quick and find the resultant vector, magnitude, so that way you can just use whatever you want. I'll draw a picture of it. We'll do U in red. Three and four. There's that vector. That's U. Then 2 and 1, do it in blue. Two and 1. So it looks something like that. Now, you put this one to this one. Now, I don't know. It seems like to me, they're doing this right. I guess that means something like that. If you decide to get it tail. But we'll go ahead and just do what we do. So we got 3 squared plus 4 squared square root is equal to the magnitude of U. And U is equal to 9 plus what? 16? 5. Okay, so we got the magnitude of U. Magnitude of V is going to be equal to 2 squared plus 1 squared. That's going to be 5 square root of 5 is equal to 2.7. What's square root of 5? I know they are, but I don't know. What's square root of 5? 2.7? 2.2. Alright, it's 2.2. Alright, so there's your magnitude. Now, what's dot product? 3 times 2 is what? 6. Plus 4 times 1 is? So what's 6 plus 4? 10. So the dot product will give us 10 over, what was that, 5 times 2.2? What was that, cosine? Inverse cosine? So inverse cosine, somebody tell me if that was, didn't it say the cosine on the previous slide? Yes, Hubert. No, Hubert. Yes. Okay. There you go. So somebody take the inverse cosine of 10 over 10 to 11.2. Check my math. What's 2.2? Okay, 11. And tell me what that angle is. 25 degrees. Okay? Now the reason I'm rounding up is because you can recall the direction. I'm not going to write all that. It's 25 degrees. So the angle between these two right here is 25 degrees. That's what they're finding between those two. You're not getting too far into the result. Now, what was your question? Why can't you do what? Now, why didn't I use the dot product on the other side? The dot product on the previous page. Right here. Why didn't I use this dot product? Well, we were given coordinates, but we still could have used the magnitude here. But a lot of times in physics, if you're given coordinates and you're going to trying to find the dot product, only the geeks will be using this. Okay? Most of the time you're going to go, okay, 2 times 4, 2 times 4 is 8, and 3 times 1 is 3, 8 plus 3 is 11. That's most of the time what you're going to be doing. I doubt very seriously that you're going to say, okay, well, first I need to find the magnitude. Once I find the magnitude, I can put it in the cosine, the cosine, but I got to find theta, I got to find that first. So you got to find this first before you can use this. So it's really kind of better that you do the coordinates quick. Okay? And let's see what they got. Let me just erase this. We got 25 degrees. Let's see what they got. Did we get, what did we get? We got 25, they got 26. They must have. Oh, we only rounded to 1 digit with the. I don't know. I don't know why we didn't get that. 3 times 2 is what? 6 plus 4. Is that what that is? Wait a minute. Why did they do 4 times 2? 3 times 2 plus 4 times what? 1. That. Okay. All right. Y'all decide what. Okay. I thought I've been doing the dot product for over 20 years. I thought I was doing it right. But let's look. I thought the dot product was 2 times 4 plus 3 times 81. Is that not what that says?
Yes.
Okay. All right. Now with that, it's got to be. Yeah, that's supposed to be a 1. Well, then I got that right. So, now, we did the square root. Didn't we get, what did we get? 5 times what? They got 5 right. Oh, there, okay. We did 2.2, and they took it all the way to 10 digits. That's why they took this. Somebody give me, we did 2.2, but they did somebody give me the whole thing. 2.2 what? That's what they use. Okay? And that's why you got a little bit of difference. I'm not going to worry about that. As long as you know how to do that one thing. That's 25. What's the square root of 25? What's the square root of 25? And they're showing you the magnitude. They're going back to the previous slides where you can find the magnitude. Okay? Yeah, they're doing baby steps. All right, try this one. A plane with, well, write it down, but we're not going to go through it. I need to get on. I want to go to the last section of. I want to go through and show you what Hold for them. Just write it down and try it at home, and I'll give you the answer. Let's see. Write that down. Just write the question down and write the answer down of 4 degrees, and then see if you can come up with it by yourself. You will be using the law of cosines on this one, because they give you two. They give you two what? 2 distances and a what? And an angle. See, this is misplaced. This is a question about law of sines and law of cosines. Y'all figure that out. We're on vectors and doing dot product, and they throw this one, unless it's got a second part. A plane with an airspeed of 192 miles per hour is heading on a bearing of 121 degrees. A north wind is blowing from north to south at 15.9 degrees, at 50.9 miles per hour. Find the ground speed and the actual bearing of the plane. Okay, I'm going to just move on to the next. 4 degrees, 3.89. And that next one, you can write that one down too. Find the force required to pull a wagon weighing 50 pounds up a ramp incline at 20 to the horizontal. To the horizontal means that there's a 90 degree in there. You might highlight that. When you see to the horizontal in your physics problems or in the future, that means 90 degrees. And when something weighs 50 pounds, that means it's going to the center of the earth. Okay? So that's why you see that 50-pound vector going straight down, not in a 90-degree angle. It's going straight down. Alternate interior angles gives you, remember alternate interior angles in geometry? This 20 degrees right here will always go right here. Because this angle is congruent to that angle. Okay? Alternate interior angle. So, therefore, you have 20 degrees here, you've got 20 degrees here, therefore, this is what? If you wanted it, 20 degrees there, 90 is 100, what?
Mr. McClure, did you say it would always be the same?
Yeah. Fine.
Okay. No, I'm not questioning you. I just didn't know.
It'll always be the same because it's 90 degrees.
Okay.
It's right here the same. So you've got a bunch of things that are congruent, so it's going to be like similar triangles. Okay? So this one.
Okay.
Okay. So now you've just got a basic triangle problem. Now, we're trying to find this one because that's the force of you. And I'll give you the answer to that one, and you can work on it and see. 2,017 pounds. And don't let it confuse you. AC is the adjacent. Just remember the adjacent. Okay? Got the adjacent. You got the angle. So you're trying to find the adjacent. Don't let the big paragraph and all the big letters fool you. You're trying to find the adjacent. I'm sorry, I was wrong. So that's the adjacent. And you've got adjacent, here's the adjacent, so this is the angle, so this is the little mainland, so this is the hypotenuse. This is the opposite. You don't have the opposite, but you've got an angle, and you can, now they're using 20, So they're putting the little man up here. So it's still on the hypotenuse, and this is the adjacent. So you're trying to find the opposite.
So it takes 12 to 17 inches
Find the force required to pull a wagon 50 weighing 50 pounds. All right? Up an incline is 20 degrees to the horizontal. Yes. Huh? Well, that's just how much. That's how much force. I mean, you could hit somebody with a couple of 100 pounds of force. You can pull a whole lot. I mean, you've seen people pull dadgum transfer trucks with their teeth, haven't you? I mean, you can pull a whole lot more than you think. And remember, that's 50 pounds. That's a 50-pound. That ain't no little red wagon you buy at Toys R Us. A 50-pound wagon is as much as a sack of feed. That's pretty heavy. So it's not that big a deal. All right, now I want to get out of this because I've gone way past what I've tested you on, what I'm testing you on. So get out of that. I could ever get out of this. Okay, let me go to the other right here. All right, I want you to look at that, and you can write it down ad lib, or you can write it down word for word. Oops. That's not what I wanted to do. There we go. And to explain the difference, I wrote this my own way. To explain the difference between a coordinate and a vector, we might say in simple terms that coordinates describe a position or a point, like a house, while a vector describes a direction and a magnitude, like a driveway, all right, or a highway or a road. A vector is the difference between 2 points, so that 2 and 3 and 5 and 7 are 2 points. Those are 2 coordinates. 5 and 7 minus 2 and 3 is 3 and 4. That is a vector. So if you subtract them, then you've got your vector. Is 3, 4 a point or a vector? And the decision must be based on the context of the query. Basically, what that means, I threw those words in there. The context. Now, one thing I did learn in English is context clues. You know what context clues are? You can read a sentence, and if you know part of the sentence, you know what the words mean due to the sentence. Okay, I can't think of an example, but you know the meaning of the word. It has 3 or 4 meanings. You know the meaning of a word in the sentence due to the context of the sentence. You know what I'm saying? Okay? Usually when you're talking about a vector, you're talking about 2 points that are given. A vector is made up of 2 coordinates. But what people forget, they forget that when you've got a position vector coming from the origin to a point, you forget that this point is what? 0, 0. So you have 2 what? 2 coordinates. You see, a lot of people forget this. And they say, well, there's just 1 coordinate. No, you have 2 coordinates. You just forgot the initial. All right? A vector is the highway between somebody's house and another person's house. When you tell somebody to come to your house, what's the first thing you ask them? Where are you coming from? First thing you ask them. And they say, Clemson. Okay, you get on Clemson Boulevard. You're giving them a what? Direction. And then you tell them how far to go. Go about 6 or 8 miles. You're giving them a what? A magnitude. All right? You're not saying 6, 5 miles. All right? When you're talking about a highway or a driveway, you're talking about coming from Clemson. I want you to hit Clemson Boulevard. Now, depending on where that person is, she's got a direction. He or she's got a direction now, don't they? If they live in France, then they know they got to go to where? Hudson Boulevard. If they live in Double Springs, or not Double Springs, that's not a good. If they live in Pendleton, they know they got to go south. If they live in Sandy Springs, they got to go west. Or not Sandy Springs, or France. If they live in La France, they got to go west. If they live in Sandy Springs or Denver Downs, they got to go east. Because Clemson Boulevard is east of Denver Downs. See what I'm saying? So you're giving them a direction. And then you're giving them 6 or 8 what? Miles. You're giving them a distance or magnitude. You're not saying, okay, you live in Clemson, all right, just go 6, 5. That's not. But what is 6, 5 in relation to a house? It's the address. Okay, it's the address. Your address. So think of the house or a point as an address. Okay, it's a point. If I tell you 304, that tells you absolutely what? Nothing. But if I tell you 304 McClure Road, then that tells you at least where my address is. But you've got to say a distinction. Okay, I want to show up the norm. All right, that's the distinction between the two. All right? Now, we're just going to get into an introduction. This only got 15 or 20 minutes. But you need to write down everything you can on these guys. All right? Because they are vectors, but they're written in a different way. They're called polar coordinates. They're based on a polar sphere. That's basically what they're done. I'm not telling you that you're going to walk out in the real world today and see a polar coordinate. You will see it in physics, and you will see it in dynamics and statics. What was that? And it will be statics, dynamics, thermodynamics, and of course any of your engineering classes you'll see it, as long as calculus 2 and 3. You're going to see another introduction in calculus 1. All right, but it's going to be a little bit more than what I'm giving you. If I give you 2, -3, see, the old Euclidean way, or the old Cartesian coordinate would be really this point right here, before y'all got educated, was 2, what? 3. Now, do you remember when I told you back in algebra, those of you that had me in algebra, I told you that the function was a fancy way of writing a line? Hold your pinky up. Well, this is a fancy way of writing the Cartesian coordinate. This is the Cartesian coordinate. This is the polar coordinate. The y is written in terms of I. Just remember that. The y is written in terms of I. If you remember that, you don't have to remember it much more. Now, what's the coordinate of this point right here? 1, 3. This is 4, 1. Now, if you want to add those two, 4 plus 1 is what? 1 plus 3 is same thing you've been doing in 10.1 to 10.3. Do not let this confuse you, and that's what it does. It's mostly, Cartesian coordinate systems are mostly academic. Mostly. I would say probably 90% academic. When you get to structures, when you get to thermodynamics, you get to statics and dynamics and physics 1 and 2, and calculus 1 and 2, you're going to see a lot of polar coordinates. All right? when you get out in the real world, you're going to see mostly just physics, X and Y coordinates is basically what you're going to see, because we live in three-dimensional space. We don't live in polar space, but this is three-dimensional space, so you're going to see an X, a Y, and a Z based on this coordinate system. Okay, so most of the time, by the time you get to Calc 3, you're going to be dealing, in Physics 3, you're going to be dealing with X, Y, and Z so much, you're going to really forget about the polar coordinates. Okay? But the good thing is, I don't want you to be, see, this one right here. You could do this in your head. 6 minus 4 is what? And what is negative 2 minus 3? Negative 5. So your answer is 2 minus 3i. If I remember correctly. 6 minus 2 plus 2 minus 3i. 2 minus 5i. There you go. So write that down. Write the. You always want to draw a picture so you can see what it looks like. Okay. Oh my, look at there. X equals R cosine theta. Y is equal to R sine of theta. R is equal to the square root of X squared plus Y squared. Do you need to write this down? Not really, because you already know it. From 10.1 to 10.3. Now they just use, a good portion of the time they're going to be using the tangent. Why? Oscar had a hunk of what? Of apple. Most of the time in physics, you're going to be given this coordinate and this coordinate. Most of the time. Alright? So that's why they're sticking with the tangent. Now, of course, you can use any trigonometric function if you find whatever values. But most of the time, they're going to ask you what the tangent is, because they're going to give you those right there. And again, this next problem, if we get a sample right here, you should be able to almost do it in your head. Well, they're not. What'd you say? That's all right. Okay, so far, everything you've been given, you should know mathematically. Okay? This, a little bit difference. This is how you rewrite something, trigonometric or polar form of a complex number. All right? Just write down R cosine theta plus I sine of theta. Just write that down. Okay, that's the trigonometric form or polar form. So if you're given an X and a Y, you can actually write it like R cosine plus I sine theta. They're just giving you some properties of all they're doing. I'm not going to go through that. Okay, here is an example of the cosine theta plus I sine theta. This is an example. Express 2 cosine theta plus I sine of cosine 300 plus I sine of 300 in rectangular form. All right, what is the cosine of 300 degrees? Well, what do we got to go back to? Special angles. You can use your calculator, lazy, or you can go back to your special what? Angle. So let's go back to the special angle. This one I meant. Special angle. Yeah. So, all right, what is 330? 330 is 360 minus what? 30. So that's that angle right there, right? So that's a 30-degree angle. 30-degree angle, take it over here. 360 And this is, okay, 360. That's all right, I'll do this from somebody else. Whatever. 60, so 60 degrees, sorry. So 60 degrees. So there's your 60 degrees, so that's 1. That's great. 2, 3, 3. All right, so what is the cosine? Cosine, Oscar had a hump. 1, 2. So the cosine is 1/2. And then what is the sine? Oscar had square root of 2. So you see, it's not hard. You've had all this. The new stuff is 10%. The old stuff is 90%. Who has a question on that? I'm not going to tell. I may give you one of these on the test, but it's going to be something like 2 cosine of 30. I won't give you. I might give you one, but most of it's going to be the special answer. And all I want you to do is be able to do this. Okay? And if you're lazy and use the graphing calculator or use the calculator, there it is. You get the same thing. Yep. Well, the reason they teach you that they teach you calculators is because they don't want to teach you anything.
Well, they were telling us.
I know several math teachers, not all of them, but several. They go to work, they hate their work, they don't want to go to work every day, so they choose those teachers should be teaching. But that's just my opinion. See, I look back on my 20 years. I should have been one of those sandbaggers, just come to work every day and just let y'all do whatever. Because we got them on this campus, but I just can't do it. Not this campus, but Tri County. We got some of them, but I just can't do it. That's, huh? Yeah, I know. Oh, we do? Okay, well, I don't. Yeah, well. All right, this, find R. You know how to find R. I don't. Okay, y'all know how to do this. They're going to ask you for. There it is. Okay, sketch it. Do A. I want you to do A, and then we'll do B. You got to sketch it first. And just treat square root of 3 as what? 1.7? Is that what square root of 3 is? So negative 1.7. 1, 2. Well, somebody check. I was wrong. You were wrong. See, that's why you go to high school. You at least you got accepted. I'm proud. Congratulations on that. It's just a lot of people find a hard time getting accepted to major universities. A lot of people. Yeah, pretty much. Try to get somewhere in that code. I mean, honestly, it's not that easy. I think it's a good thing, even though it is Ohio State and they're overrated. But anyway, what? Only you would know that. Okay. Well, Ohio State is one of those that, like Clemson, would be suffocant compared to North Carolina or South Carolina. Yeah, they got that. That's why it's called basketball tobacco road. All right, so here it is. So that's negative square root 3. And this is 1. So I'm going to go ahead and figure the magnitude. It's going to be square root 3 squared plus 1 squared is equal to 3 plus 1 is 4, which is equal to 2. Oh my gosh, we've got a special angle. Now, what is the angle? I'm going to go ahead and figure this angle. Oscar had the 1/2. So, and you can put your in the calculator. Oscar had the sine. Sine of theta is equal to 1/2. Of course, you're going to be 60 degrees. And what is 60 degrees over here? What's 180 minus 60? 120. So you got a magnitude of 2 and a angle of 120 degrees. And of course they're doing it in, what's 5 pi over 6? Check me. I think it's 128. Pi, 180 over pi. Yeah, should be. No, it's 30 degrees. I'm sorry. 30 degrees would be 150. I don't know why I did it. 60 degrees would be 150. This is 150. Degrees.
Priority 1 message coming in on secured channel.
Because this is shorter. If it was square root of 3, it'd be up here, it'd be 60 degrees. This would be square root of 3. And that's that. Okay? The whole point is, what is mu? That's mu. And the only thing you have to do there is say, oh, that's 3x. X is equal to negative square root of 3. Y is equal to 1. That's the only new stuff. The rest of it's all trivial. Now, what about that one that's got negative 3 guy? What's x? X is equal to 0. Y is equal to what? Negative 3. So that's that one. We already found R. R is equal to 2. We already did that. And there it is, quadrant 2. I'm waiting for the last one. There we go. There it is. 270. And then you can put it in 3 cis. Now remember, when you see cis, that means I in the sine and cosine. That's what that means. Cosine and I, see it right there, cosine and I sine, that's cis. You'll see that in some books. All right, that's it. Okay, so make sure, this is what I want you to be able to do. Make sure you can do 10.1 through 10.4, and I'll just curve some of the questions in 10.4. I'll curve them to where you don't get into the real difficulties, okay? All right, y'all get out of here and have a good day.
So homework 10.1 to 10.4?
Yes.
All right, gotcha.
All right. So, y'all good?
Yep.
All right. I'll see y'all, I guess, when? Thursday? When's our final? Thursday at 10. Be here Thursday at 10.